This is the ROS Developers Podcast, episode 114.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo from The Construct, and today I would like to dedicate this episode to all the ROS developers over there that are working on making efficient warehouse robots. Using ROS, of course. So ROS-based warehouse robots. If you are in that field, if you are trying to make the picking systems easier for all the warehouses around the world, this episode is dedicated to you. Today, we are going to learn more about how warehouse picking robots and cloud tools for this. But before going into that, let me remind you that if in case that you need to learn more about ROS, then you have to visit the Construct site. You know, we are the experts, the lead experts in teaching you how to learn ROS in a fast way. Our method works with simulated robots as well as real remote robots. So if you go to our academy, you will learn ROS by practicing with online simulations and also with our remote robots that are located in Barcelona, Spain. You will connect to those robots and practice with them along the awesome lessons that we have there. So those robots and those simulations, they are ready 24/7. Check our website. I will put a link here on the show notes if you want to check it. Okay, and now let's go to the meat of the episode. Okay, so that's what you are waiting for today here. Again, and then let me introduce you Gajamohan Mohanarajah. Gajan is the founder of Rapyuta Robotics, a company created in 2014 as an ETH spinoff from Switzerland. And it's focusing on cloud robotics. Welcome to the podcast, Gajan.
Thank you. Thank you for coming all the way to the office, and thank you for setting up the meeting.
Okay, yes, this is the second time that I visit you.
Yes. It was 2018, I guess,
yes.
when we first met.
Yes.
Yeah.
And a lot of changes.
A lot of changes, yeah.
A lot of changes. A lot of growth, I would say. And I visited on the old offices,
yes.
The previous ones are awesome. So I saw, just to let you know to the audience, that I was watching a demo of their latest product, and then it's awesome. It's amazing. You will see some videos also about it. It's pretty. But then let me ask you, what is the current mission of Rapyuta Robotics?
Yeah, so the mission has always been, we as most of the roboticists, we believe like the work that in Japanese we call it the 3K. In English I think it's called the 3D, the dirty, dull and dangerous tasks.
Okay.
So there are a lot of these tasks that people spend a lot of time, and we strongly believe that these kind of work should be automated. And while doing that, we believe like it's not just going to be a one superhuman robot. It should be many small robots connected and working together to solve these problems. So our mission, as we put on the website, is empowering lives with connected machines would be the mission.
Awesome. So I didn't know about this definition of the 3Ds.
Yeah.
And then 3Ks in Japanese.
So in Japanese, I think it's originated from Japan. It's called 3K. So it's Kitsui, Kitanai, and Kiken. So it's somewhat loosely translates to dirty, dull, and dangerous.
Okay. Awesome. And then, based on this mission, what is the business of Rapyuta?
So in Rapyuta, like I would categorize us as a robotic software company. But having said that, we believe like so one of the biggest hypotheses we have is robotic solutions come in different shapes and sizes. The hardware may be different, the application, how we use the core technology may be different. But we believe that, but there is going to be a common set of software that can be reused across many solutions. Of course, you need to do some additional work to get the solution out. So Rapid.io platform, which we can, I think, talk in more detail later, we call all these common software as the platform. And then using the platform, we try to build solutions to the customers. It's typically one of the strategies when you start with the platform. You first build your own solution to show that the platform is great, and also like it's a great initial use case for you to polish your own platform. So to summarize the answer, what we do is we work a lot on robotic software, but at the same time we do a few solutions to as a use case of the platform.
Okay, and this platform, so it's called Rapyuta.io?
Yes, yes. And some of them is available for others to use, but there is also a lot of internal components that we use inside.
Okay, so now that we are talking
so
about
we went
this,
into that discussion.
Yeah. So tell me about this. So what is this platform about? So what is the role of this platform?
So I would so as I said, like we believe like there's a common denominator when it comes to software robotics in robotic solutions, and our platform I can categorize as three main layers. So the bottom layer is the infrastructure. So no matter the software, this software is going to run in a distributed way. They have to talk to each other. They have to be configured. There has a whole life cycle which is distributed. So there has to be tooling to support these things, especially in a customer location. You can't send your engineer every time to your customer, etc. So remote operations and stuff. So we call it the infrastructure layer that we have, and some of them is exposed as public right now. The second layer is the typical, I would say, the ROS components. We call it internally the behaviors. So the navigation, the perception, some of the motion planning that we do, etc. So that we start with ROS, but as you know, when we hit production, you need to do changes and polish the whole thing to increase the robustness and simplicity to operate, etc. Then the final layer, I think that's where we put a lot of effort nowadays, is the multi-robot coordination. So it's great, like one robot is moving around, and it's 2022, so it's not a big problem. But now the challenge is how do you get multiple robots to collectively or collaboratively work with each other, work in an uncertainty, work with people, etc. So that's the final coordination layer in Rapyuta, and I think that's something similar as to open source related projects we do is Alika.
Alika.
Yeah, Alika is one of our open source project. It is a framework to do behaviors for teams of robots, which I think did a few ROSCON presentations, and we also have a large simulation to check the multi-robot system
to test
and before you deploy, etc. So these are the three layers: the infrastructure, the individual behaviors, and then the multi-robot coordination. So we collectively call them the Rapyuta.io.
Okay. And one question which is now it's very in fashion, right? In the ROS world, is about the fleet management. So this layer that you mentioned about coordination of robots, can I say that this is a fleet management part?
Yeah, I'm not sure. Like it's also defined properly. So for me, like what that layer does is that layer talks to the enterprise systems. So the enterprise systems decide what needs to be done.
What is an enterprise system?
Enterprise system is system that manages the orders from customers.
Okay, and this is in the customer side, right? It's not inside Rapyuta.
Yeah. So those are the things that tell us, okay, it can say like, I want to move a certain item. I want to ship an item.
I see.
And the shipping time would be, I need to ship by 8 o'clock.
And this, for clarification, so this is done by the company system using your API, talking to your software, Rapyuta IO. Okay.
So without robots, it has been the people who receive that order and execute.
Okay.
So in our case, the top layer receives the work, and then we decide, okay, what needs to be done, which includes like, okay, which robot is going to be assigned to which tasks. So it's kind of there is a task assignment involved. And task assignment, of course, has to consider the route, the planning, the congestion, etc.
Okay. Yeah. So, okay, I am not an expert in definitions, okay, but in my mind, that would be in what we are talking about, fleet management.
Yeah.
Because you have to arrange different robots, which is your fleet. You have several robots in order to accomplish this task that has come from the corporate enterprise system. So you need to coordinate, right? To decide this robot is going to serve this, is going to pick this and this and this item.
Yeah, so in that definition, yes, that's the top layer.
I'm not the master to define. No. It's for. I'm asking you this question to clarify for the audience. So
yes. So in that definition, yes, the top layer in Rapyuta.io is fleet management.
It's like a fleet management. And when we are talking about picking and place, are we talking also about the robot doing actually the grasping of the object?
No, so this is technically speaking, it's more assisted picking.
Okay.
So we are enabling people to pick faster and walk less distance.
And for that you have developed a panel with a software that simplifies a lot, right? It's very easy because I was trying this morning.
Hope you enjoyed it.
Yes, it was very funny and also very intuitive to use it.
So because most of the pick workers are part-time, so it's very hard to train. You cannot train them. So they may be like very newcomers. They are just thrown into the field. Okay, now you work with the robot. So it has to be dead simple for them to operate.
So exactly. So that they don't require training. And also one of the things that surprised me a lot is this reinforcement that the robot is given all the time to the picking person, so the person that actually picks the object and puts on top of the robot, because that can happen. It happened to me. I was talking to your colleague, and then suddenly
forgot where to go, right? You forgot where to go next.
Yeah, exactly. I didn't know what to do, so because I forgot, but then the robot was telling me by lights, I am next one. I can be the next one, and also on the screen was telling. So I can recover myself very easily.
So I mean, those are very necessary conditions for operating with people. They are very complex, and they, I mean, in Japan, people are the warehouse people are super serious, but at the same time, they have to sometimes go and help others. And when they come back, either robot is not there, or it has gone somewhere, or they kind of forgot the things.
Well, that I'm telling you because that surprised me a lot, because I never thought about this thing, you know.
We also didn't know. So when we went to the market, it has to teach us, I would say.
You learn it the hard way. Okay, great. And then so this solution with the robots connected to your Rapyuta IO platform, then it's what you call the AMR solution. AMR solution.
So PA stands for pick assist. So it's an assisted picking. AMRs because they are autonomous mobile robots. So we use that term to describe what we do. It's kind of hard to it's relatively hard to explain sometimes, because when you initially show, some people think like there is a one-to-one connection. It's basically just carrying. But here, what you can see is, if you see in the videos, the ratio of people to robots is about 2 to for every person there is about 2 to 3 robots. So the idea is like let's focus on the picking, which is more complex, and the carrying is relatively less complex, but it's more tiring for the robot. So it's a balance how you split the work.
Okay, makes sense. Makes sense. And one question is that you are from Sri Lanka,
I'm
but
from Sri
the
Lanka.
company is here in Tokyo. So but it also is a spin-off from Switzerland. So how all these mixes?
Yeah, so let me connect the dots. So I'm from Sri Lanka, and so after finishing high school in Sri Lanka, I was very excited about robots, and that's the time when Honda's Asimo robot came out. So I wanted to study in Japan, and I got a government scholarship to study here. So I came and did my bachelor's and master's in Tokyo Institute of Technology. Then for my PhD, I went to ETH. I was working in the Robotics project, and then after graduating, the project inspired me to do something on the cloud robotics domain.
What's
the
the
company?
You were from ETH. You were working on this
Robo Earth.
Robo Earth, exactly, exactly.
Part of the members, one of the thing. It was a very exciting project. That was at that point of time, I think there was only very few working on.
Yes, exactly. It's a pioneer in cloud robotics.
So we were like, yay, the cloud is the next big thing, and there was a lot of. I also got a chance to meet a lot of very smart people who got inspired me to do something more on robots. Yeah. Yeah.
Okay, and then so you were doing the PhD, but then the company was built here.
Yeah, so for us, I'm one of the co-founders, so there is one more who, he's also from Sri Lanka. We both studied in Tokyo Institute of Technology together, but he went into finance afterwards. And then when I was graduating, he was like, hey, we should do something more exciting than finance. So I said like, yeah, so we have these few ideas on cloud robotics. And for us, like, I mean, the choice of Japan was more obvious because most of our 20s we spent here. So I probably know better on business here than Sri Lanka.
Okay.
So it was more of a natural choice.
Yeah.
But at the same time, as you know, like, I mean, you come here quite often. So one of the things, like, compared to even the other developed countries, Japan has a very declining population, working population. So they really see the need. There is no question of a robot is going to take my job. They're like, okay, we need people to help us.
Yeah, because there is no people to take the job.
Yes, exactly. So there is a huge demand, and also I think that culture-wise, it's a culture they love robots.
Yeah.
So it's a great opportunity to start, and recently, like, we are also like starting to move some of our business to the US to sell, but definitely Japan still remains the home, and the significant most of the sales come from here. Yeah.
Okay.
Yeah.
Awesome. Then talking to that, so recently at the ROSCON of this year, ROSCON 22, for the audience, you participated at the ROSCON panel, which is called Robotics Startup Companies in Japan. So what can you tell us about the startup ecosystem here in Japan? Is it a good ecosystem to build the startups?
I'm not experienced with the other ones to really compare, but I would say I have no complaints at all. We had very good funding, very good people to support, and one of the challenges, definitely, the Japanese customers have very high standards in terms of delivery and quality and stuff like that. So you need, but at the same time, they're willing to work with you for long terms. So if your demo fails, they're not going to say goodbye. They're going to come and say, okay, how can we help? So that balance is a good thing, especially for robotics, because in robots, compared to just pure software, you're going to have trouble.
Yes,
right?
Exactly.
So that's a great, and they have a lot of good feedback. So most of the things I was showing you downstairs were coming from the feedback from them, and they spend a lot of time analyzing and telling you the things. So I really appreciate it, and I can't complain.
Okay, very good, very good. Well, so I can't complain, for example, on my own country, on my own country, so I can't complain because that's terrible. It's terrible to get some
is it funding?
Funding, exactly.
I see.
It's terrible.
Yeah.
So nobody is interested on that, and the conditions are terrible. And that's why I wanted to know more about the Japanese ecosystem, because we don't know. We usually know about the American one. It's very good. It's very well organized towards creating good startups and so on. But I think that most of the audience doesn't have any idea about
Yeah,
Japan.
so
That's why.
in that sense, I mean, compared to the US, I would say, I mean, the seed, I mean, Japan is one, I think, third or fourth largest economy, so I think they still, they have a good funding, seed rounds and stuff like that. But sometimes you may hit the ceiling when it comes to Series C, Series D. There's only a few funding agencies you can who can support that. But at the same time, now things are getting global, right? So if you are Series C and D, you can go out to US and get, or wherever the money is, right? So that should not also be a problem.
Okay.
Yeah.
Okay. Then let me see, because we have talked several of the points here that I have in my questions. So more things. Let me ask you about more things. You kind of mentioned already about the things that you have presented this year at the ROS Con 2022. One of them is the simulator based on Unreal Engine, right? So you mentioned that you needed to have this simulator in order to be able to simulate fleets of robots. But then my first question is why you couldn't do that with already existing simulators instead using Unreal Engine for that? So
we were big gazebo users, but then there were limitations when it comes to scaling in the order of 30 or 100 robots. 30 to 100 robots. Things were slowing down.
How many robots?
30 to 100 robots, somewhere around that area. Is it
I would say 3
Even
to
4 robots.
3 to 5. I would say 3 to 5 is
yeah.
just terrible.
Since it's a
sorry, gazebo guys, I love you. Don't hate me.
I was also trying to be polite because it's a ROS developer thing. Yeah,
I love you, but we have to say the things as they are. So, well, I'm saying, okay, so it's me. All the blame on me, please.
Yeah, so there were limitations, and we did explore a few options. And at that time, I think, what was the one that has from Switzerland?
Webots.
Webots, yeah, that was also like closed source at that point of time. So we were looking for some framework that is more that can handle more scale. So one of the thoughts was like the game industry, because they have a budget that is like, I think 100 times more than what robotics have. So they have developed good systems. So why don't we leverage that system? So what was out there was Unity and Unreal. The reason for Unreal was mainly it's kind of open source. You can if you want to get your hands dirty, you can actually go and change code. And plus, it was C++, and you don't want to you don't want to introduce one more programming language into your company. So those were the reasons for Unreal. Although Unity seems to be popular nowadays, I would recommend Unreal. We are trying to match to those the features and stuff. And it's also open source, so you can.
Yes, it's very interesting that you mentioned about this language, because that's the same conclusion that we at the Construct we arrived, and we were doing some experiments with other simulators, and the one that we decided at the end was to use Unreal Engine because of the same thing, because you can program in C++. So any developer that is working on ROS then doesn't have to use C# on Unity, for example, right? But this is strange that most of the other simulators that people are putting out there, most of them, they are based on Unity, which requires this extra step. Yes. It's very strange that
it's but I can kind of understand the reason, because I mean, one is you want to go deeper, and the other one is you want to set up something quickly. Unity is much more easy to set up.
Easier.
Okay. And I think definitely that's a huge factor for adoption.
Yes.
We are also trying to create a few Docker images, which simplifies the whole thing. We'll see how it goes. This thing.
And it's open source, the
yes,
simulator?
So I mean, Unreal is open source, not
but
by
your version.
Yes, our components are also open source. So yes.
Okay. So I will put a link to your Git, where people or the audience, you can download all this material. Okay, and you call it distributed simulator. Why? Well, what this simulator is distributing?
So of course, for few robots, I think you have also the option. Depends on what you want to simulate, right? Do you want to just simulate the high-level thing and then kind of teleport the robot for the low-level things? You can run in a centralized mode. So our distributed intelligence teams, they run it on single instance. But if you want to really simulate the whole warehouse, including some of the navigation stacks, you want to put some people in and simulate like congestion with people and robots, etc. You need the full stack to run. Otherwise, you're not going to be, you're going to deviate from the real warehouse. So for this purpose, we run a distributed simulation, and we use this feature. I mean, any game engine, they have this mass gaming nowadays, right? So you as a player, you have your computer,
Yes.
and then you play, and then within the computer, you are in the local world, you are moving, and most of the heavy lifting is happening in your computer.
Yes.
But there is a central server that is trying to sync the state of the worlds between the players.
Okay.
So so in our system, the player becomes the ROS nodes that gives the command to the robot. So we utilize that system to leverage, so that we don't have to build anything special for us.
Okay, so that would be like several robots. They are executed in different computers.
Yes,
That's it.
Different computers or different nodes in a cloud system. Typically, you would like to run in a cloud system. These things. So you spawn the PCs, spawn the nodes that run the heavy lifting, and then you have a server that synchronizes the states. And you have right next to the local world, you have the ROS commands, ROS communication. So especially when you have this high frequency navigation commands going down, you don't want that to flood across, right? So your ROS node is very close to your virtual world, which also reduces the
communication. Okay. I got the picture. And what are you using this simulator for? Is for unit testing? Is for continuous integration?
Yeah, so definitely the integration testing is one of the things. But some other things we use for in the business is, let's say you go to a customer location and you have some information on them. And when you make a proposal, especially for large deals that have like 20, 30 robots, it's sometimes hard for the customer to understand, will I really get my money return on investment, right? So what we do is we collect data, and then about a week's data, and then run the simulation and show that, okay, this is before and this is after, and this is how much you could save when it comes to picking efficiency. So that simulator is being used as the business analytic tool to make proposals, and also later, like, you know, when we can make some additional proposal. Hey, if you change your layout like this, your whole efficiency may go out. So this is also used as in addition to the developer tool, and it's also used as a business analytics tool on this one.
Okay, because you can visualize different situations and provide this to your customers.
And Unreal is beautiful, so we also use it as a marketing tool.
Okay, that's right. Okay, and then you mentioned that it's open source, and then it works with which version of ROS?
We work on, it supports only ROS 2. I forgot, I think we support even the latest one.
The Galactic or Humble?
Humble.
Okay, so it's for ROS 2. It's being developed for ROS 2.
Yeah. If you want to use with ROS 1, you need to use a bridge, which is not very good. So
yes, and very complicated. It's complicated, but if you need to learn how to do it, you can go to the construct and check our course that teaches you how to do it. Even the action bridge, we are teaching how to use the action bridge. That's a little bit tricky. So
should send my engineers over there, right?
Yes, exactly, great. And then what is the RCLUE? What is this?
RCLUE is an Unreal Engine client. So you think of in the architecture diagram, it's in the same line as RCL CPP, RCL Pi. So one option can be just, I think, I'm not sure. Unity maybe just, you have some message transports and then you communicate. But what we want to do is we want to make ROS as a first-class citizen within the Unreal Engine ecosystem. So RCL UE is like, it's kind of C++, but it caters to all the Unreal Engine's constructs. So if you have an actor inside Unreal Engine, it automatically becomes a ROS node.
Okay.
So
and
you don't
is that a plugin that you put into your
Unreal
model?
Engine. Yes. Yeah. It automatically comes into your model. So Unreal Engine has a lot of visual tools to also program, like behavior things.
Yeah.
So this one can automatically connect to those things and get the things. So you don't have to do a lot of heavy lifting when it comes to communication.
But then what is that for? Is for publishing topics of the
topics. Typically it will support
topics.
whatever the CPP is supporting, it will support all the things. I don't think we support the action server. I need to check. But yeah, we start with topics and services. Yeah.
Okay, topics and services. Okay. And that's also open source, right?
Yes.
And there is a presentation at the ROSCon about all this. So for the audience, if you want to learn more about this, I will put a link also to the presentation because it has been published already. So you can check more details about those components.
You should ask the audience to contribute too.
Okay, yeah, of course, that's the opportunity, yes. And please contribute to this. If you find this useful and you are putting some modifications, interesting modifications for the whole community, that we can use it, then please contribute and do a pull request to the Git. Of this. One final question about this simulator is about the import of the robot models, because that's a problem when using other simulators, especially the ones in game engines, is that in Gazebo we have our models and you can find the model of the universal robot or this, I don't know, maybe there is a model, a URDF model of your Rapyuta robots. But when you have to go into Unreal or Unity, then you have to start from scratch.
Yes. So
how do you do that with the model and with the controllers?
Yeah. So I think I'm not sure if it is already released. We have a prototype of URDF and SDF importers. So you may have to. It's not like very straightforward. You may have to do some tweaks, but it works for most of the things. So we recently also, in the ROSCon, if you have dropped by our booth, we were kind of demonstrating all the robots that got imported. So yeah, as you said, it's a valid problem, right? That's what I think keeps Gazebo also going.
Yes.
It has a lot of robots. So but the standard is open, so I think we should be able to write converters to move the models into the Unreal world too.
Okay.
But having said that, definitely it doesn't have robots, but it has so many other assets when it comes to building an environment. Warehouses, you name it, then they look so real. So that's a benefit to us. So if you can take the robots,
even you can buy them. So you can buy. You need an environment of whatever. So you go to a shop and then you buy it, and then you got it. You got it, and it looks realistic.
It's very realistic. So we also use. We also work a little bit on the forklifts. So to train the pallet detection, we train it on Unreal because it's so realistic. You don't have to. Developers love it. You don't have to go to the warehouse to collect data and stuff. So yeah, that's also one of the usage, I would say.
Awesome. And one question is about the controllers. Because the one thing is the model, but the other one is the controllers that make the robot. So the wheels turn, the joints turn, and also for the sensors. So to capture sensors into a ROS topic. So
we have tried the standard sensors like LiDAR and stuff like that, and using RCL UE, you can also write your custom sensor. Controllers, yes, I think that's something we should start working on. We have the basic controllers that can be sufficient for our robot.
For yours, yeah.
But I'm sure, like for a general purpose controller, I think we don't have it. That's something we can work with the community to do something.
Okay, yeah. Just wanted to know the current state.
Yes.
So the audience that is there, well, they can decide to use it. Also, maybe to collaborate to include new controllers or new sensors or something. So if you are there, you are ROS developers, they're listening, then maybe they will be engaged if they find this simulator interesting. Then now I want to switch topic. Is about the Alika open source framework that you mentioned at the beginning. So can you tell us more about what is this software about, this framework about?
So we jokingly say it's a glorified state machine within the company, but it's for multi-robots. They go into different states. So it's a behavior control mechanism when it comes to multi-robots. So you can assign. So basically, robots have different behaviors. It's a collection of behaviors, and which behavior to do at what point of time is the whole high-level planning problem, right? So this is a framework, and it uses the hierarchical state machines to define the behavior and to choose the optimal behavior based on certain inputs from the user. So it makes it easy for us to do multi-robot coordination, especially like when the state machines can become more complex.
Yes.
So for the ROS users, I think hierarchical state machines can do something, or a similar framework is like the behavior trees. And behavior trees are maybe more powerful, but this also gives you a decent framework to do that. And we plan to support behavior trees moving forward too. So you will have a framework, so you can define things, and it also has some solvers.
What does it mean, solvers?
Solvers means when robots have to take decisions. The solvers become very custom to your solutions. So in our case, let's say there is an order, very busy order, all assigned in the same location, but then the robots actually figure out, okay, actually like everyone is going towards that location. So what we do is sometimes, okay, now the solvers worked between the robots and then reassign depending on the congestion, or reorder within themselves. Although the high level assignment is done, but then they do a small swap so that you can reduce the congestion. So these are like small mechanisms. They talk to each other. So it assumes the robot and robot can talk to each other. And then based on that, they can make some decisions compared to a more centralized way of doing things. So this was in 2020 ROS World. We had a almost 40 minutes presentation.
So then this one I missed it completely.
So you can. I think we have a lot of examples on how you can build these multi-robot coordination systems and stuff. So feel free to take a look at it. This was actually originated as a system to coordinate these Robot Cup mid-league soccer robots. So when you have a common objective and you have multiple robots, how do you move these robots and in a more distributed way is the problem that it is trying to solve.
And then so making this similarity with the soccer teams, then that would be your solution. The Alika framework then allows you to establish not only a coordination at a central point, but also between each one of the players in this case, because they can talk to each other. So
to be more precise, Alika is primarily distributed.
Primarily distributed. Okay. So it's like in this game of soccer, there is no the manager. It doesn't exist. It's between the players that they talk between them, and then they organize themselves. Okay, interesting. Then I will put a link to the Alika software also, but also especially to the presentation on ROS World 2020.
That will help you understand. That's a better explanation than me.
No, that I understood. I understood perfectly. And then I want to ask you just a few questions more,
Yes.
and we are done. Then it's about so you started your company as a pioneer in cloud robotics, and now there is a technology which is about cloud, which is Kubernetes. And then, so some projects already have appeared. Some weeks ago, I interviewed, for example, Tomoya Fujita from Sony.
He was here actually a couple of months ago.
Okay. Then he was explaining us about his project on Kubernetes. You can check the podcast also there. And then, so I would like to ask you about your opinion about using Kubernetes for robotics and especially for ROS-based robots. So what is, are you using this in your solution? Are you using Kubernetes?
Yeah, so we use a variant of it, but the need is there. So what does Kubernetes do is basically in the cloud there are a lot of computers, and it kind of abstracts the management of the whole applications, right, which are Dockerized. So for me, like especially when you have multiple robots, robots are like servers on wheels. Mm-hmm. So how do you manage or control the life cycle of the whole software is a similar need. So I think definitely Kubernetes is needed. When we started, we didn't have Kubernetes. We had to build our own something similar.
Yes,
kind of
exactly.
things. So that's great. And I think the cloud domain, I mean, there's a lot of business happening. So there's a lot of improvements going into technology, going into those things. I think if possible, we should leverage those technologies as roboticists.
In the future, but then if I have understood your answer, then I understood that you conceive Kubernetes as something useful for deploying the applications and the updates of the applications inside the robots.
Yes. So no, so Kubernetes was mainly focusing on the cloud, but one of the challenges, you cannot use just vanilla Kubernetes because most of the software may be running on the edge or on the robot.
Yeah.
But ideally, you want to maintain. For me, like it's end of the day, it's which computer should run which software, right? Mm-hmm. and with what configuration. So, but there are some other projects that spin off from Kubernetes, like Kube Edge, and that focuses on the edge and provides extra functionalities, especially when compared to two computers in a data center, they are highly connected, fiber optics, and then, but when you go outside, it will be intermittent connection. Like you may lose connection and then you may come back. So how do you handle those things? So, but I think we can get a lot of inspiration from the cloud world, the IoT world, and put together these technologies to build something. I think we try to not to reinvent some of the wheels. So we try to get information, but at the same time, you may have to do some tweaks and things to fit to the robots, because compared to IoT, for example, robots produce a huge amount of data. So some of the IoT things may not work for you. But to answer your question, yeah, Kubernetes and the related technologies out there, I think we should leverage them and so that they help us build better systems.
Okay.
Yeah.
Well, I wanted to know your opinion because in our experience at the concert, what we found is that the problem with ROS is that the Dockers that you built, they are so huge for even the simplest application because they require they have a lot of requirements. Then, in my opinion, so Kubernetes was thought when you have microservices, microsystems, so then you can quickly launch and deploy a lot of new machines very quickly.
Yes.
But in the ROS world, in my opinion, it's not there because of this massive Docker machines that you need for even a simple. So to launch navigation, so you want to launch 3 computers, 3 different machines with 3 instances of navigation. So you have to download this Docker file, in which contains a lot of gigabytes that takes a long time to explode. So you cannot be closing and launching machines in a dynamic way, which is for me one of the strengths of Kubernetes. You cannot be launching and closing as you need it because the whole system is so slow. It's so slow that doing this, and just wanted to see if you have any similar experience, or my point of view. I'm not an expert in this subject, and we are not experts in this.
We're also not experts. But I maybe I can check with my team. But some of the activities, comments I can make on your statements are definitely like, for example, our developers make Docker images, but then our QA team or SRE team takes it and they go on a diet. So you remove the unnecessary pieces that you don't have to have in the Docker. So one is you can, make the Docker image smaller.
Slim
down version of it.
I like this. Come on, put the Docker on a diet.
The second thing is we have built tooling around Kubernetes. So for example, we have something called the CLI, the command line tooling. So it's like you describe, okay, in this warehouse I want this version of the software deployed in these robots with this configuration. So you write it as a YAML file, and then you say like I deploy, and then this is a command line tool, and typically like SRE people or developers would like prefer that. So then it will automatically do that. So I think vanilla Kubernetes definitely will have its own thing, but if you can build some tooling around it, that'll help you.
Okay, we'll see more about Kubernetes and robotics in the close future. Then we're about to finish. One question more is I saw that you are hiring. So which kind of positions are you looking, and for which skills are required for the audience? Here there is a lot of people listening, ROS developers eager.
I mean definitely like we hire in all across the domains, starting from pure developers that work on core ROS. But as when you build full solutions, you also need people who are comfortable with large business systems, databases, and backend systems, the UIs that you saw. And since it's the audience, probably students are listening, we definitely hire a lot of interns. So if you want to just experience Japan, or there's only a few companies that operate in English within Japan. So you can come for 6 months and then have a good time, learn about the country and stuff. So that's definitely, interns we have a constant flow, and we believe like interns and then converting them to full-timers is a great way to hire, because the skill set, and they may be a good fit because so that's one thing. And of course the QA role nowadays, but we need to sell a robot, so definitely business. So if you because it's really hard to find people who know a bit of technology, also has a knack for selling. So if you feel like, okay, I need to try to selling, that will be also quite exciting for us. And finally the project managers, they're the core people who kind of bond between the business and the engineering. So you can take a look at the website and apply.
So I don't know about the business roles and management roles. I don't know about that in our audience, but who knows, because this audience is not.
But interestingly, like all our project managers are engineers, ex-engineers, and then even our top lead business is ex-engineers. So I think as a robotics company, it may be a fate that we have engineers.
Yes, but this is strange, because when I talk to engineers, and I am one of them, so we don't like to be managing projects or people. What we want to do is to do engineering, but at the end we have to do this kind of things. So like, for example, in my case, that's exactly the case. But all the other engineers that I talk to, they tell me also the same. No, I just want to do engineering work, but then that happens, right? That happens that at the end you find yourself managing people.
No, but as engineers, we love structure, right? And frameworks. So I think if we can use those things for other things also, it'll be fun.
Okay, well, in any case, I will put a link to the hiring page of your company, and then the audience there, you can have a check and check the different positions or internships or management. So you can also do that. Great. Then final question: what can we expect from Rapyuta in the next years? What are the secret projects that you are working for?
It won't be a secret if I tell you. Yeah, so we're working on definitely like when we went into the logistics domain, we learned a lot. The customers taught us a lot. And picking is just one part of the operation that happens in the warehouse. So we are really focusing on what are the other types of solutions that we can give to the same customer. So you don't have to put a lot of effort on selling. You can just have the customer. You can just have to upsell. So in that sense, well, we started talking. Is the next couple of months we'll be releasing an autonomous forklift solution. So the picking robots that you saw are for small items, but when it comes to large items, it has to be forklifts. And there is already a lot of declining in the fork drivers. Also, so I think there's a good market need for these things. But forklifts are big, so you need to be very careful, and safety is the primary concern. So that's something we are super excited about to release in 2023, and there'll be more coming.
Awesome. So let me know, and then I would like to review it.
In your next Japan visit,
I'll
take you there.
Exactly. So, okay, so that is all for
Thank you very much, Ricardo. It was very fun talking to you and seeing you after 4 years.
4 years, exactly.
Let's meet more often next time.
Yes, exactly. No, but that was because of the pandemic. That's what stopped us, all us.
Yes.
But okay, so thank you very much, Gajan.
Thank you very much.
Thank you. And that is all for today. So see you the next week with a new lesson from the experts. And until then, keep pushing your ROS learning.